How does memory paging work in operating systems? Have you ever wondered how your computer manages to run multiple applications smoothly without crashing? One key technique is memory paging. Let's break down how this process works in operating systems. Memory paging is all about dividing memory into manageable pieces. The operating system takes the logical memory, which is what programs see, and splits it into fixed-size blocks called pages. At the same time, it divides the physical memory, or random access memory, into frames of the same size. This matching size helps keep things organized. Each process running on your computer has its own page table. This table acts like a map, showing where each page of a program is stored in physical memory. When a program needs to access a specific piece of data, the central processing unit generates a logical address. The memory management unit then uses the page table to translate this logical address into a physical address. This step is crucial for finding the actual data in memory. Now, what happens if the program tries to access a page that is not currently in physical memory? This situation is called a page fault. When a page fault occurs, the operating system steps in to load the required page from secondary storage, like a hard drive or solid-state drive, into an available frame in RAM. Sometimes, this means swapping out a page that is not being used as much to make space. Once the page is loaded into memory, the central processing unit can access it, allowing the program to continue running seamlessly. This whole process enables the operating system to implement virtual memory. Virtual memory allows programs to use more memory than what is physically available by temporarily storing inactive pages on disk. Different operating systems handle paging in their own ways. For example, Windows uses a page file on disk to support virtual memory. It also has tools like Task Manager to monitor memory usage and page faults. Linux, on the other hand, uses a swap space or swap file and employs smart algorithms to decide which pages to swap out. macOS follows a similar approach with its own swap file system, tailored to its hardware. Paging is not limited to desktop systems. Mobile operating systems like Android and iOS also use paging to manage limited physical memory. However, excessive paging can slow down performance because accessing data from disk is slower than from RAM. In summary, memory paging is a vital technique that helps operating systems manage memory efficiently. By dividing memory into fixed-size blocks, translating addresses, and swapping pages between RAM and disk, operating systems can run multiple applications smoothly and effectively.